Hey everyone.
Hey, hi. How was your weekend so far?
It was good. It was good.
Nice.
Hey Mateo, Kartik. Thanks for speaking.
Soyoung, how are you?
Good, good. Let's see. We'll wait a minute or two for folks to trickle in. Hi, Srini.
Hey Srini, good to see you.
Hey man, how's Seattle?
Seattle is good. We're having
good.
good weather finally after what, 5 days, 6 days of rain. So
Nice. I was just
Since you're not drowning like New York City is like underwater right now. So
oh no, we know how to deal with water in Seattle. That's the one thing I guess we sorry, Soyoung, what were you saying?
Yeah, I was just in Seattle yesterday. There was rain and then it stopped.
Yeah, it's better weather now. So yeah.
Cool. James is here. All right. Cool. James, do you want to start us off?
Yeah, 1 second.
Yeah, we're super excited about Symbl, and we also
Yeah, we are also we have a lot of things to talk about. So
yeah.
Yeah, hopefully the talk will be interesting to everybody. Yeah.
Great. Let me share my screen real quick and then get started. Okay, so hey everyone, welcome to Multimodal Weekly webinar series hosted by the team here at Tor Labs. We've been meeting, every Friday at 1:30 p.m. Pacific time, and this is our 19th session, if I'm correct. Here's some of the topics that we tend to cover, in our webinars: news research in multimodal AI and foundation models, innovative multimodal applications in different verticals, video and multimodal projects we like to share, and sometimes tutorials and guidelines on using our technologies, platform APIs. In the past, we have a wide ranging of speakers, from researchers focused on multimodal language model to startup founders focused on video storyboarding, and ritual augmented generation, as well as developers who building open source solution and tackling the intersection of industry and research. So for the webinar today, we have one speaker, Kartik Talamadupula, who is currently the director of AI research at Symbl.ai, and he will give his presentation about Nebula, which is a conversation-focused large language models built on communication data, and this is a product came from Symbl. And yeah, Kartik was part of our Discord community, and I reached out to him and have a very good conversation with him, I think a few weeks back, and we discussed kind of his journey and how he sees the evolution of conversational AI from traditional audio processing to NLP, and now with innovation LLMs, how it's going to change this paradigm. And yeah, super excited to see to hear about some of the challenges of language understanding, multilinguality, and of course multimodality. Yeah, quick just note for folks who in the chat, feel free to send your question on Zoom as you observe his presentation, and we have a short Q&A session towards the end, led by Soyoung once Kartik finish. So with that, I let you start sharing the screen and get started with your presentation.
You guys can hear me fine, right?
yes, loud and clear.
You guys can see my screen. Let me move this off the screen so I get a little bit more real estate over here. Okay, super. Thank you. I want to thank James and So Young and 12 Labs for this invite. I am very excited to be here to be talking about Nebula, which is a conversation-focused large language model that's been built on a lot of data, but specifically on communication data. So I'm Kartik. I work at Symbl.ai on the research team. More information about me, you can go to my website. You can also follow me on Twitter. I'm on LinkedIn, all the usual places. And just really quickly, I'm currently working on Symbl. Before this, I used to be a senior research scientist at IBM Research back on the East Coast. And I'm currently based out of Seattle on the West Coast. I've been working in AI for about 15 plus years now. Some of that work I'll talk about in today's talk. Hopefully there's some overlap with the kind of stuff that folks are interested in over here in this series of seminars. But yeah, at any point, if you want to reach out, feel free to drop me a line. My email is on my website, and I'm available basically on all of these platforms. All right, so with that, let me jump into the agenda for today's talk. And before I go into this, I want to say, yes, you can hold your questions to the end or put them on Zoom, but also, feel free to ask me questions during the talk. I fully intend for this to be interactive. I think it's nice that we have an hour, about 50 minutes left. And so, I don't have a whole lot of slides, right? I really just want to focus more on specific pieces of work and on making sure that we all sort of understand that and, we get to talk around that. Okay, so with that, what I'm going to do is I've split the talk into 3 parts, right? Hopefully that'll make it a little more interesting for everybody here, given, the interests in this group and so forth. So the first part, I'm going to be talking a little bit about a history of conversational AI. So that's mostly going to focus on the conversation modality, right? And notice how I, snuck in conversation as a modality. It's not something that you usually think of when you talk about modalities. You think about, text or vision or audio or, those kinds of things. But I do actually think that text doesn't do justice to conversation. I think it is a very special modality in and of itself, because there are many nuances when you're talking about people interacting with each other. And in fact, with the pandemic, we pretty much found out that, conversation is the key to everything because we started working remotely. We had all these meetings on Zoom. We're doing this webinar right now on Zoom. So, conversation is a little different from text. So that's part 1. Part 2, I'm going to talk a little bit about some research challenges, right? So I'm going to tack on the vision modality, right? So specifically about how the use of vision can either help with text-based tasks or the other way around. Can text-based language models help with traditionally what you would consider a task in the vision or video domain, right? And so I'll talk a little bit about this notion of Visual-Semantic Embeddings, which has been around for a while. And then I'll talk about 2 papers. One of them is language models as planners for embodied agents, which some of you might have sort of seen this work in the past. It's work out of UC Berkeley. And then some work that we did a few years back on adding the visual modality to text-based models in order to improve their performance. So I'll talk a little bit, briefly about those research papers. And then the second half of the talk, part 3, I'll talk more about the real world, right? So that's where I'm going to talk a little bit about our conversational intelligence platform from Symbl.ai. And I'm going to talk a little bit about the journey, the story of how we came to build our own language model from scratch, right? So we had all of this communication data that we were looking at, all of these use cases that we were getting from all of our customers. And so that kind of all coalesced around us making multiple iterations of this Nebula model, which, like I said at the beginning, is a large language model for conversational use cases. So that's kind of the outline of the talk. And again, I can slow down, speed up, depending on where there is interest from people in terms of what you guys want to hear. So yeah, let me go forward with this. Okay, part 1, history of conversational AI. Yeah, I couldn't resist basically sharing this graphic, right? Everybody thinks we're in the middle of a hype cycle right now with AI. And this is not new, right? We are just the latest people to be embroiled in a hype cycle. This graphic is from 40 years back almost now, right? This is from 1984, 85, I think, right? And this kind of shows you a little bit about at that time, there was a big AI hype cycle that was going on at that time. People were talking in the billions of dollars. I understand now we're talking in the trillions of dollars, but of course it's been 40 years and there's been a lot of inflation. But it's interesting to look at this pie chart, right? And to see what the areas were that people thought at that time were very promising in AI, right? And so you can see that almost half of it is devoted to all of these different modalities. You're looking at like the visual systems, you're looking at languages, you're looking at voice, natural language processing, all of that. And the interesting thing is 40 years later, we're still in that same hype cycle in some sense, right? The numbers are different slightly, right? This was something that Gary Marcus dug up on his Twitter account. Gary Marcus being a famous critic of large language models and the development of them as it has happened in this era. So I just thought this was interesting, right? That we're all in the middle of this AI hype, but don't forget that this is all cyclic. People have been here before, and it goes up and it goes down. Okay, so with that away, this is a slightly more interesting graphic. So this is something that I pulled out of, and by the way, this graphic is from 2022, so it's already terribly dated, right? Because a new thing seems to come out every week, it seems. And so anything that I pulled from last year is going to be dated. But I think this is useful because it kind of classifies, when we're talking about conversational AI and conversational systems, it kind of classifies the history into 3 different eras, right? There was the rule-based era, then the machine learning era, or the statistical, era. And then now we're, of course, in the middle of this deep learning era with huge models and massive amounts of data being processed and so forth. So a couple of things that I want to point out on this slide. One, of course, is, ELIZA, which was one of the first universally known conversational intelligence systems, right? ELIZA basically was, if you haven't heard of ELIZA, you should go look it up right now. It was basically a program that was created by Joseph Weizenbaum at MIT. And for its time, it was basically groundbreaking. People started using it as everything from a companion to a confidant to even like a therapist. And so ELIZA is something that greatly influenced the development of chatbots and conversational AI systems going forward. So I think ELIZA first came out in 1966. And so it's been now, 70 years almost. One of the things I wanted to say here was, there was a fantastic article in the Guardian newspaper, I think a month or so ago, I think in July, where they talked about Joseph Weizenbaum and ELIZA and the lessons that we can learn from it. I think it's called Here Lurks Danger or something like that. So if you're interested in these kinds of things and where AI is going, I think you guys should really dig that up and read it. I can drop some resources. But anyway, so that was the rule-based era. And then kind of the first 20 to 30 years of research in conversational AI stuck around this pattern of, put a whole bunch of rules and patterns manually, and then you have an agent that can respond to you. Then we kind of started transitioning into a more mixed era, right? So you started having these statistical techniques, you started having machine learning techniques. And so we started getting these systems like Siri, for example, is a very well-known system. And then we started having, all of these things that now are a part of our daily lives, Google Assistant, I have one sitting on my desk right here, Alexa, a whole bunch of other things, right? So that was kind of the second era, which we saw rapid progress in the late 2000s and the 2010s. And then, of course, now with the advent of the transformer, which is the big sort of religious moment in AI, we've kind of transformed now into this era of very large language models. Like I said, this slide kind of ends. If we were to extend this, I think this curve would become even more vertical in 2023 because we have new models that come out basically every week now. And now we're not even just talking in the billions, we're talking in the trillions of parameters for some of these models, right? So that's one view of, how conversational AI has kind of developed. There's another view that you can put onto this, right? Which in addition to looking at some of the research developments, you can also look at some of the systems, right? So what are the embodiments of these things, right? What did it really mean in real life for people to be using some of these systems? So if you were around in I think the early 90s, there were these systems which I think persisted well into the 2000s, where basically they were trying to do keyword spotting and matching, right? So these were the systems where if you called in, you would have to say a very specific thing, and then the system would route your call based on what you said, right? So I think AT&T devised this, but then everybody sort of grokked onto it. Everybody was using it. This kind of developed in the early 2000s. There were a whole bunch of people, nuance research came up with it. AT&T also had some contributions there, where we moved now from a scripted thing saying, that the customer had to say something very specific to more of an intent detection and determination kind of paradigm. So you could say whatever you wanted, and then there were a bunch of pre-decided intents that the system would try to classify that utterance into, and then it would try to direct your call accordingly. And then, of course, there was also, there was the Kalo project from DARPA, which famously Adam Chayar and a whole bunch of other people worked on, and Siri, was the result of that. And then there were a whole bunch of other assistants that kind of caught on very quickly as well. And like I said, today this stuff proliferates all around. There was also the Jeopardy IBM Watson project. And then there were a whole bunch of other use cases with respect to, search, voice search, and things like that. So this is another view of, some of that history of conversational AI systems. How did they develop, what happened, and so forth. If you want to kind of go a little bit more technical, right? If you want to focus on a specific part of that era, right? This is a nice slide to look at for that, right? This gives you an idea of when we say, neural conversational AI, what do we really mean by that, right? So these are a nice representative set of papers that basically, and again, a lot of this stuff that I'm talking to you about, because I said history, right? This is all pre-LLMs, right? This is pre the era of really large language models that can basically do anything, it seems, right? Although not really. So on this axis, you have a bunch of different papers that are listed. If you start all the way from Oriol Vignal's paper on neural conversational model, and then you have a whole bunch of papers that were around this notion of how do you generate dialogue? How do you generate natural language, right? So there was Antoine Bordes and other people from Facebook research at that time who were working on this space. I remember a great talk that he gave, I think it was in NYU back in 2016 on that. There was also deep reinforcement learning for dialogue generation. And then people also went into sort of personalizing some of these agents, right? So how do you make the outputs of these models more natural sounding, right? So that people don't realize that it's a machine at the other end of it generating these things, right? And then you had, of course, transformers kind of transformed everything, no pun. And then you had a whole bunch of embeddings as well. Word embeddings obviously is what everybody talks about, but we also had like positional embeddings, segment embeddings, all kinds of different things. So what I'm going to do is I'm going to zoom in a little bit on one of these papers here, right? And you will know the reason I'm zooming into this in the next 5 seconds. The reason I'm zooming into this paper is because it's actually a paper that I wrote, that a bunch of us wrote back at IBM Research. So this is about multi-resolution recurrent neural networks, right? So again, like I said, we were trying to basically condition this to dialogue response generation. That was the use case. You can imagine that this is something that's very important for all kinds of enterprise scenarios, right? And so this was something that we worked on with Julian, who was the first author, was a student at the University of Montreal at that time. And so let me give you a quick idea of what that problem basically was, right? So you essentially get a dialogue context, which is this column on the left-hand side over here that you're looking at, right? And so this is Ubuntu tech support, right? There is an actual really well-used corpus called the Ubuntu tech support dialogue corpus, whatever you want to call it. And so we were basically looking at that corpus as an example of tech support. And essentially what we were trying to do was get the system to complete, to troubleshoot, the problem of the user and to complete the chat, right? So on the left, you have the entire chat up until that point. And then the task is basically for the model to generate a response to that thing, right? So you can look down here for a simpler viewing of that. And then the things in bold over here are basically all the different models, right? So the Mr. RNN was our model, multi-resolution recurrent neural networks. And then there were a whole bunch of other hierarchical encoder-decoder models at that time that were being used. So that's what you have with the HRED and the VHRED and so on. And essentially what the insight that we developed, that we brought to this thing, which is what this paper is about, if you go and read it, was this notion that instead of modeling this problem as an end-to-end natural language generation problem, right? What if you could do this at 2 levels of hierarchy, right? Which is where the multi-resolution comes in, 2 levels of resolution, right? So one is, of course, the natural language level, right? But there can also be a slightly higher level, a coarse representation, if you will, right? And in the coarse representation, what you're doing is you're no longer trying to generate an entire sentence, right? You're just trying to generate the relevant entities and the relevant actions, right? Think of it as you're trying to generate the relevant nouns and verbs that the agent has to respond with. Okay, and so that's the coarse representation that you see over here, right? This is your generic sort of encoder decoder model essentially. But the idea is that instead of having one of them, you now have two of them in parallel, right? And you have this coupling between them, between the coarse representation and the natural language representation. And so if you look at this table on the left, you can actually see the model response and you can see the coarse response, right? And so the coarse response is basically trying to predict what we should respond with to the user so that it feels like a natural response to that user, right? And then the natural language part, the model response, is trying to fill in sort of the natural language parts of it to make it, to make it more cosmetically nice looking and so on, right? So you can actually see that there is a difference when you compare the outputs of the different models, that Mr. RNN with the activities and the entities, that is the verbs and the nouns, is able to actually generate more detailed responses, right? Because now we can start talking about specific tools like gedit, or we can start talking about specific files like the bashrc file and so on, right? And so that was one of the key insights that, if you want the output of your language model, because that's what this was, right? This was a language model, maybe not a very large language model like the ones we're used to today. Then what you really want to do is you want two steps, right? You want sort of, in today's parlance, I guess I would call this, there's the pre-training step, which trains on a whole bunch of data, right? But then there's also a fine-tuning step that kind of conditions a little bit more on more specific data to that use case or to that particular scenario. So that was this piece of work that we did. And that's kind of a little bit of a deeper dive into some of these quote unquote historical papers, right? Because again, everything pre-LLM seems to be history at this point. Okay, any questions at this point? I can pause. I'm trying to see if there are any questions in the chat. Thank you, James. I see that you've been posting some of the resources from that. I think it's very useful if people want to follow up. I do also have a slide at the end where I provide some links and so on to some of these things. Okay, all right. If there aren't any questions, let me move on quickly to part 2, because I do want to have about 20 minutes, 25 minutes to talk about the LLM, which is the exciting part. Okay, part 2, research challenges, right? So now let's add on, right? So we've figured out that these models, right, whether they're rule-based or they're statistical or they're neural network-based pre-LLM, we've realized that they can talk, right? They can create conversation, they can respond to users, and they can chat with users. But can we also make them see, right? And is there something to be gained from adding a visual modality onto this, right? So this is a slide. I think a lot of you are familiar again with the examples on this slide, right? So this happens to be the paper about Visual-Semantic Embeddings for multimodal language models. So this came out actually in 2014, I think in NeurIPS. I think it was still NIPS back then. And essentially the idea here was, in addition to language as a modality, can you also add on vision, right, as another modality? And the idea being that if you want to accommodate all of these, different modalities, you now have to update the loss, the training loss of your function in order to take those things into account, right? And the kind of thing that this produces is kind of this, you can do this kind of hybrid these kind of hybrid tasks, right? So here are examples of this. Basically, you take a picture of that school bus and then you remove yellow and you add on red, and then you suddenly start now getting pictures of red buses, fire trucks. I think this might even be like a picture of the London Tube, which I guess semantically is in the same region, right? And so you have that ability. This is one of my favorite examples. You take a bunch of kittens in a bowl and you subtract that bowl, and then you put kittens in a box. And obviously, kittens love living in boxes. So this was one of the early papers that really talked about, can we combine more than one modality in order to improve the performance, in order to improve the analysis of these different systems. So what I'll do is I'll talk about 2 different papers that that focus on this idea, right? And I think you'll also now start getting an idea of where this talk is heading, right? When I'm basically talking about, okay, we have data from one specific modality, and then can we add on something from another modality in order to extract better performance, in order to extract, better output and better outcomes, right? That's basically the meta theme of this, if you were searching for something like that. So let's see. All right. So let me first talk about this paper, language models as zero-shot planners. So this is work by Wenlong Huang and Peter Abil and a couple of other folks. out of UC Berkeley. And the idea here was basically, so two directions, right? The first direction is, can you extract knowledge from large language models, right? From text-based large language models, and use that in order to improve the performance of embodied agents, which are in a world that has multiple modalities, right? It might have a visual modality, a video modality, there might be aspects of visual understanding and so on, right? So that was one. And so in this case, what they essentially ended up doing was they have a task for their agent. And what they're trying to do is they're trying to prompt the text-based LLM to generate the steps to break down that task, right? So for example, if your agent wants to shave, what are all the different steps that it needs to take, right? This is kind of like a planning task, right? If you want to shave, what are all the different steps that you need to put together for that? Or if you want to apply lotion and so on, right? And there were basically two ways of doing this. One is you can use a pre-trained, what they call quote unquote, a causal LLM, right? Which will give you the answer straight away, right? Let's say if you're trying to apply lotion, what is the first step? You squeeze out a glob of lotion, right? Or you can use a standard LLM and you can kind of do this, masking procedure where you have a set of admissible actions in your domain for your agent. And you can basically try to extract the action with the maximum probability, right? So in this case, out of all of this, this whole list of admissible actions, maybe the action with the highest probability when you're trying to apply lotion is to pour that lotion out into your hand, let's say, right? And so they basically evaluated this on a whole bunch of LLMs, large language models. And basically what they did was they took the text that is generated by those models and they gave it to this agent that you see on the right, these agents that are executing in a simulated scenario where it's no longer just text, but you have vision and you have to actually perform these actions and you get feedback from the world, right? And so the interesting thing here on this slide, I think, is to look at the level of detail or the difference in the level of detail between the outputs of all these different models. Again, this is a paper that's, I think, about maybe a couple of years old at this point. And so some of the models basically, they are from that time, right? So you have Codex, which came out of Meta, and you have the GPT-3 models at that time, which were the state of the art. And then also you have a comparison to GPT-2 and to human performance. And so the idea here is basically you're prompting the language model to produce sub-actions, which you can then give to your agent that's executing in a multimodal environment. And you can improve the performance of your agent that way. Because if you just tell the agent, this is how you browse the internet, or this is how you brush your teeth, if you just give it that one sentence, it's not going to know how to do it. But then if you break that down into the constituent steps, then there's a higher chance that the agent will actually be able to perform those actions in whatever environment your agent is executing in. So that was one piece of work there. And then the other piece of work that I want to talk about does the reverse, right? So this is some work we did last year where we were essentially looking at, okay, in a text-based scenario, can you use the vision modality in order to improve the performance of your agents? Okay, so let me give you an example of this, right? So for this, the baseline environment that we used was Text World, which is this thing that was created by some folks over at Microsoft Research. And you can Google it. Text World is basically this sort of environment for reinforcement learning agents, where the idea is basically it's a text-based game, and the agent has to interact with the game by giving the game the next action in terms of like a sentence or in terms of text, and then the environment processes that and sends back an observation to the agent, and then you go back and forth. So it's kind of this reinforcement learning problem. And so in Text World, so here's an example of a Text World problem, right, on the slide. So you have this description, you are in the kitchen of the White House. A table seems to have been used recently for the preparation of food, yada, 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 right? So you have like an entire paragraph that describes the current situation. And usually the way that people have tried to solve this problem, including a lot of work by us in the past, is purely through text, right? So you try to model this as a text understanding and text generation problem, and then you try to get the agent to produce the next action or the next natural language utterance, and then you go back and forth on that. But what we wanted to do was, in addition to the text, right, can you now also add image, right, and add an image encoder, right? And then can that improve the accuracy of your action selection? So can you get your agent to pick the right action more often and in more cases and faster if you add some vision information to that as well? How did we do that, right? There's a couple of ways of doing that. One is you can take the text content of the problem that's given to you and just really the most naive thing you can think of, which is stick this into an internet-based image retriever, right? Literally stick it into the Google search API, right? And get the list of images that come back. So for example, if I took, dark staircase and I stuck it into Google image search, or you can see some examples over here. If I stuck, let's say, table lamp on sofa into Google search, what is the top image that would show up as a result of that? But you can also do another interesting thing, right? You can do a more generative thing. So by that time, when we started working on this, I think in 2021, by that time, we already had good models, right? At that time, it was mostly GAN models, generative adversarial network-based models that would actually generate novel images, right? And now, of course, we have great models that do this, foundation models and LLMs that can basically generate great visual representations. There's Symbl.ai, there's a whole bunch of other work in this space. But at that time, some of these models were sort of in a more nascent stage. But what you could do is, instead of relying on just the images from the internet, which can be very sparse, you can also try to generate custom images for these, right? So for example, dirty pie plate in kitchen cupboard, right? That's not something, I'm sure you could find something on the internet for that, but look at how, closely this is able to approximate that in terms of the generation, right? Or if you have something like rotten red apple on an armchair. And really what we're trying to do over here, let me actually show you some more examples of these, right? While we're talking through, right? I hope some of this is visible. The small text doesn't really matter, but really what you want to focus on is, this is the action that was given to the agent. So for example, examine patio chair, that's an action. And these were some examples of the images that were generated by the visual model in response to that. And you also have below that the corresponding activation map, right? So where is the agent actually looking in that picture to find an example of a patio chair? And really the idea behind doing this, just in a nutshell, at a very high level, the idea behind doing this was to teach the agent, what does it mean for something to be on something, or something to be put into something, or something to be at a certain location, right? So all of these prepositions and sort of connective words that we take for granted in language, right? You want your agents to be able to understand what those things mean. And if you use only text in order to do that, that's not going to be a very rich space in terms of semantics. So if you add on vision, then can the performance of your agent increase, right? And so I'll end with this. I'll just show you some of the results, right? So in the green, you have basically the system that combines both the text and the vision modalities. We called it Seen It. It's supposed to be a pun. And we compare that against just text-based models and also some of the language models that were available at that time. And you can see that the performance actually goes, it jumps quite a bit when you combine this visual information as well, right? And we evaluated this both for problems that were within the distribution of the problems that the agent has seen, but also those that were out of distribution, right? So just to make sure that there's no artifacts in terms of the agent has learned everything that is there to learn within this particular distribution of problems. And so this was a very interesting insight that, if you add on an extra modality, in this case, the modality of vision, you can actually greatly improve the performance and the output of what your agent is trying to do. So that's one example of this. There are a lot of other works as well that try to do something like this, something similar to this. You can look up the paper. There's a whole bunch of resources in the appendix as well. And so that brings me to the end of the second part of my talk, right? So some of the more research-oriented challenges when dealing with the vision modality. Okay, now for the third part, right? So what have we learned so far? We've learned that if you tack on additional data from a new modality, usually your performance will improve. Usually you will be in a position where you can beat the best models of that time, the state-of-the-art models of that time, okay? So now let's see if we can apply this to a real-world situation. And so this is where I'm going to talk about what we as a company, Symbl, we do with conversational intelligence, and how we built this Nebula large language model. I'll also end with a quick demo of the language model. I'm sure you guys all want to see that. Okay, so real world, what are we talking about when we talk about the real world, right? What do businesses want? And this is based off of, hundreds of conversations that we've had with our existing customers, potential customers, clients, prospects, everybody in this space who is trying to include language models in their engineering pipeline, who's trying to include language models as part of their product, right? And so this is a table that I put together. This is available on my LinkedIn as well. I think I posted this earlier this week about what it means really to commercialize with LLMs, right? And I kind of split it into two worlds. The world on the right, world two, is more the larger companies and the larger models that are out there, OpenAI, Anthropic, or I should say Amazon at this point, Meta, Microsoft, all of these folks. And then the world one is more smaller companies and startups like us who are working on some of these use cases as well, right? And so you can see immediately some of the differences that jump out. One of the big differences that really matters to a lot of customers as we talk to them is this notion of incumbency, right? Meaning, are you a company that's just offering a language model because everybody else is offering a language model, right? Or do you have some incumbency in this space? Like, have you worked in this space? Do you have experience of the kind of problems that customers are trying to solve in this space? That's actually a big deal to people. Like, they want to know if you are merely experts at giving them a language model, or are you experts at the problem that that particular industry is trying to solve. The other one, which comes up quite a bit, is this notion of support, right? So a lot of the larger providers, they basically give you a model that you can access on the cloud, and that's it. That's the end of it. Good luck trying to get through to support in OpenAI, and get them to customize something for you. Whereas with World One, with the smaller companies and so on, we're able to do faster model iteration. We're able to fine tune some of these models. We have better update velocity. And a lot of this matters to a lot of customers, right? Because look, remember, everyone's use case is unique to them, right? And they want to make sure that your language model, you're able to fine tune it to their use case. That's one part of it. Another aspect of this is deployment flexibility. So one thing that we're seeing very clearly now, especially as some of the risks of these foundation models and large language models become apparent, is that a lot of people are worried about deploying these things just on the greater cloud, right? And they want some flexibility in terms of, hey, can I take your model and apply it and deploy it on-prem? Can I put it in a format where I can control the data, I can control the compliance requirements and so on, right? That is a huge requirement for a lot of customers. Data reuse obviously is another one. Unfortunately, I think the industry has seen far too many use cases of just data being used without people's explicit consent, without people's permission. And now, customers are worried about, hey, if I send data to your LLM, how can I make sure that you're not actually going to use that to train the next version of your model or whatever it is, right? And so that's one part of, that. And of course, this notion of hallucination, right? Hallucination has always been a problem with large language models. And one of the ways of countering that, of course, you can look at guardrails, but one of the ways of countering this also is, can you empower your models to actually say no, right? So can you get your models to say, what you're asking me for does not exist in this particular context or in this particular set of documents that you're showing me, right? That's an incredibly hard task, because right now models try to please a little too much, right? And I'm sure you all have seen examples of these. And so these are some of the things that are important in the real world to a lot of real world customers that we talk about. And, XKCD is one of my favorite comic strips, and this just keeps coming back in every era of machine learning, whether it's statistical, whether it's deep learning, whether it's large language models, right? Really, this is what a lot of people are doing at this point. It's like, you look at a language model's output, it kind of doesn't look right. Okay, then you shake it again and try to make it right. And we really need to go towards something a little more systematic in this. Okay, so how do we systemize this, right? Let me start with a quick overview. I'm not going to go into the full details of this slide, right? But really, the reason that I'm flashing this slide is to show you guys some of this, to talk about this notion of incumbency that I was talking about, right? That we've been around now almost for more than 5 years. And we've been working on a bunch of these use cases with a lot of our clients. And so where that starts off is on the left-hand side over here. When you look at the input that a lot of our users basically bring to the table, right? It's, first of all, it's multimodal input, right? So you have audio, which is obviously the recordings of different calls and conversations that they want to process. Sometimes there's also video as part of it. Text obviously is a big part of this, right? And so these are all, and of course, these come in many different forms, conversation transcripts, chats, emails, text messages, all kinds of different things. And you have to support a whole bunch of different protocols to be able to accommodate all of these, both in a streaming fashion as well as in an async, after the fact analysis kind of fashion. And so on top of all of this input, right? So this is the communication data that I was talking about, right? And so remember the other parts of the talk where I was talking about you need some differentiator so that you can extract better performance from your language model, right? And so in this case, this communication data basically is going to be the differentiator, okay? And what we essentially were doing was long before, the OpenAIs of the world and so on had this model where you could play with ChatGPT, let's say, right? And really what you were doing was they're giving you the service and then they're collecting your usage data, right? We had this kind of thing where we had free APIs that people could use to process their conversations and so on, right? And we had this opt-in system where people could opt to share their data with us, right? So they could say, okay, you're processing this data for us. You can store a copy of this communication data and you can kind of build things on top of that, right? And that's really the origin story of this Nebula model, right? That we started realizing that there is a huge demand in the market for a language model that can basically model and work on communication and conversation data, right? And so that's where a lot of this thing came out of. And so we built multiple iterations before we came out with the LLM. It's not like, day one, we had this realization and then day two, we built the large language model. We went through many different iterations. There was, we had task-specific transformer-based models first that were doing things like sentiment classification and detection, entity detection, Q&A, all of that. We also had a lot of semantic and context similarity-based, embeddings. And so those were used more for detecting sort of intents and trackers and specific phrases and so on. So now this generative model, the large language model Nebula, just happens to be the latest iteration of all of this, right? And it builds upon a lot of this acoustic and language data that we had access to, that we have been collecting for a long time, right? So that's basically what Nebula does. And as with all large language models, it frees you from what I like to call the tyranny of APIs, right? So in the past, you would have to call a bunch of different APIs just to get one task done end to end, right? But the advantage of having a language model is you call one API and you kind of fine tune your prompt that you're sending to the model for use with that. So I'm not going to go into all of the details of, the ASR and all of that. This is kind of how we built up our incumbency as a platform. And this is how we got a lot of that data that we were going to use in order to fine tune the language model. One thing I do want to pause on and explicitly recognize is this notion of redaction and privacy, right? This is very important to us. And this was something from the beginning that we were compliant with, PII, PCI, PHI, right? So personally identifiable information, health information, credit and consumer information. And so that's something that we take very seriously. We maintain a whole bunch of compliances, including HIPAA and SOC 2 type 2 and a whole bunch of other things. Because when you're dealing with communication data, you have to make sure that you handle that data correctly, right? So, and that's something, again, that's very important to customers as well. I pointed this out earlier. How do you handle their data? Because very often their data is actually not even their data. It's their customers' data, their clients' data, right? So you have to be very careful in enterprise situations when you do this. Okay. How do you create an LLM for conversation use cases, right? And so really on a high level, I want to show you guys what we did, especially when it came to fine-tuning our model, right? So the pre-training, obviously, we tried to train it on as much data as we could get our hands on, but the fine-tuning is really where the differentiation for the model comes in, right? So here are two different views of that fine-tuning data set that we looked at. One is more of a task-based view, right? So what are some of the conversation-specific tasks that are represented in this LLM, right? So there are things like summarization, sentiments, obviously, note-taking, topic detection, entity and intent extraction, generating action items, but also some interesting use cases like the use of business tools, right? So a lot of enterprise conversations, what you want to do out of them is to log it into, let's say, a CRM system like Salesforce, or you want to, use Gmail to send out follow-up emails to people, or you want to use, let's say, a tool like Zapier to connect all of these different things together and so on, right? So our model has seen a lot of different examples of these kinds of conversational tasks in its fine-tuning data. And then on the right-hand side, what you see is yet another view of that fine-tuning data, right? Which is now, what are the kinds of communication data that the model has seen, right? So there's sales and support calls, there's contact centers, but then there's also all the other stuff about, internal emails, chats, meetings, webinars, status updates, and then also some more general things, right? Like things like YouTube videos and podcasts and other media that's available out there, right? And all of this is in an attempt to basically get the model to understand what does it mean to actually have a conversation with someone, and what are the different nuances and intents different things that underlie conversations. Actually, to Srini's point in the chat, it has actually seen a lot of table-based tabular data as well, right? Because we do have a lot of customers, for example, who work, let's say, with Tableau or something else, right? And so they want the analysis to be in a format that is compatible with those things. I'll show you an example of that when I go to the demo real soon here. So, okay. That's basically this Nebula model, a large language model for human conversations. Let me run through some quick tech specs for the model, and then we'll do the demo, and we'll see if you guys have anything that you want to run through it at that point. So again, trained for multi-party human conversation understanding, fine-tuning. We talked about that, fine-tune on a whole bunch of conversational tasks and all kinds of communication data. Right now, we offer an 8K token context window. 16K is coming in the next couple of weeks, but really we want to scale this up to 32, 64 and further, because obviously conversations tend to be longer than a lot of other texts. And so you want to make sure that you're able to accommodate some of these long transcripts and so forth. And so, that is something that we're actively doing all of the time. And also the model is multilingual today out of the box. In addition to English, it supports a few other languages, and we are able to fine tune it to support other languages and dialects and other things as well. And really that's more of a product market fit kind of thing, right? So if we have customers and clients who have a use for a language that is not currently supported, then we would look, at those things as a higher priority. Just some quick notes about the architecture. I'm not going to go into too much detail in this, the transformer architecture and the notion of attention and self-attention. I think everybody today is aware, more or less, at some level with this thing. We actually have two variants of the model. We have a small model and a large model that we offer, 8 billion and 42 billion respectively in size. I talked a little bit about the training itself and the data that underlies that training. There were some optimizations, obviously, that we had to undertake in order to make the model operate at scale, because that's very important to us as well, right? That this is not just a plaything. We need a model that is able to scale up, that is able to operate at scale, whether it's on the training side of things or it's on the inference side of things, right? So we've been looking at a lot of improvements on how to improve serving performance for all our different clients as they come online using this model. And then quickly, before I go into the demo, let me just give you an idea of where the model stands today, right? So this is the part where, remember in the other parts of the talk as well, I was talking about if you add a different modality, you actually start seeing now better performance than the state of the art, right? So in this case, we compared to GPT 3.5 Turbo as the state of the art, because even if you go to OpenAI's website, they basically say if you're trying to perform conversational analysis and conversational tasks, GPT 3.5 Turbo is actually the best model to do that right now. And so we compared our model, the small model as well as the large model against that on a number of different metrics. So the Rouge 2 score, the BERT F1 score, and Nebula does beat GPT 3.5 on these metrics. We also compared it on a few summarization metrics as well, right? Because summarization happens to be one of those core tasks when you're talking about conversational understanding, because you can't really do much with a conversation until you understand the gist of what happened in it, the summary of what happened in that conversation, because then you can do all kinds of other things like translation and analysis of different things and extracting topics and intents and entities and sentiments and all kinds of things, right? Did you know, by the way, this is something I learned very recently, that when you're watching your Netflix or any other show that has subtitles, right, or it has dubbing, they don't actually do a direct machine translation, right? They don't do a text-to-text translation. What they do is they take the entire script, right, and then they do a summary of that, and then they produce a translation. And the reason that they do this, obviously, is because they don't want unnatural translations coming out, right? Like you need the context of the conversation that's going on between characters, right? Not just that one line, in order to produce a more natural looking translation. So that was something that was very interesting. I was just learning about that. Some more results, in addition to things like accuracy and so on, you obviously also want to look at things like bias. And so on this chart, lower numbers are better because this is a representation of how much bias there is in the output of the model. And so you can see, for example, that our models actually, in this case, the small model, let's say Nebula base, actually has better representation numbers on gender. I mean, granted, look, a lot of these numbers, you have to take them with a bit of a pinch of salt, because, small differences don't really mean a whole lot, right? Unless your model wins, obviously, then it means a whole lot. But really, it's more to show that these models are in the ballpark. They're kind of in the ballpark of the state of the art, which happens to be GPT 3.5 Turbo. And then also, a little bit more of benchmarking against other models as well, in addition to GPT 3.5. Now, one of the challenges of doing this kind of benchmarking against other models is obviously nobody's going to, especially for the closed models, people are not going to open up access to their models for you to run a whole bunch of experiments, right? So what you need to do instead is you need to find these benchmark data sets, right, on which people have already run their model and published their numbers. And then you run your model on those things and you say, here are my numbers on these things, right? So that's what we did, for example, with HellaSwag, which is one of these benchmarks that came out of the Allen Institute of AI and some other researchers. And HellaSwag is one of those data sets that it focuses on common sense knowledge and on sentence completion. And so it had two characteristics that we were really looking out for. One is it closely mirrors what you would do in a conversational setting, right? And two, it has a very high baseline human performance, right? So to give you an idea, look at these numbers on this table, right? Human performance on HellaSwag right now is something like 95.6, right? 0.956. And so none of the language models we have today approach anywhere close to human level performance on those things, right? Which makes it a great benchmark, right? Because a great benchmark is one that hasn't been solved, right? And so that's one of the reasons that we picked HellaSwag. And again, one point I want to make here is with significantly smaller size than a lot of these other models, we're actually able to do as good as, or sometimes even better than some of these other models that are being offered out there, right? So we've put our model through the paces. Like, we're for real and we're treating it as such, right? We put it through its paces to evaluate it against these other models. And then real quick, before I go on to sort of the roadmap and end with the demo, we also have an embedding model that we are offering. Obviously, embeddings are something that have become very important now for people who want to use a lot of their historical data and knowledge in order to condition the output of a large language model. And so in that spirit, we offer a Nebula embedding as well, which is a version of, again, the model that powers our large language model. Again, we've done a bunch of evaluations on this against, if you look at embeddings, the state of the art is OpenAI's ADA 002 text embedding. And so on open benchmarks for text-based similarity, we are actually better than them. We're able to beat them on some of these benchmarks. And we're also lighter and faster in terms of throughput and in terms of latency than OpenAI's model. So we have that available as well, because a lot of our customers are trying to build solutions that incorporate both historical data and knowledge as well as generation use cases. So then you kind of sequence the embedding model with the large language model in order to achieve that. Okay, and then last slide, roadmap, right? Where are we going with this? Because everyone always wants to know what's coming next, what's happening next, right? And so obviously I talked about the increase in size of the context window for both models. Same thing for the embeddings. We're trying to accommodate a higher number of dimensions and also larger context lengths as far as the length of the documents or the chunks that you can send into the model all at once. One important difference that we are working on. So currently the model is instruct-based, and we have a chat-based version of the model that should be available in the next couple of weeks. And so then we'll have both modes available, both instruct-based as well as chat-based. And then I talked a little bit already about some of the multimodal challenges that we're working on with the model, trying to use some of our audio data as well. And of course, the multilingual support as well. Okay, so with that, let me quickly go do the demo. All right. And so, especially for you guys here at Multimodal Weekly, I basically found a video game transcript, right? A chat in a video game kind of scenario. I found a transcript of that. And I'm going to do all of these things. I'm going to demonstrate all of the things that the model can do on top of this transcript. This is our model playground for the Nebula model, by the way, right? So you can apply for access, to evaluate the model via this playground. And it has a bunch of preloaded transcripts that come with it. And then you can add your own conversation transcript as well. So let me give it something really simple, right? So summarize this conversation using bullet points, right? And so this will give you an idea also of really what is going on in this conversational transcript, right? Again, this is a model playground, right? So I don't want you guys looking at things like latency and tokens per second and all of that, right? That can be optimized for the API version. What I really want you focusing on is the content of what the model is generating, right? As part of this. And so this is a transcript where there's a player who's basically going through a new game or a new world, and it describes all of the different things that happen during that chat that's going on between the player and the different characters in the game, including a non-playing character. That's the NPC that you see over there, right? Who is trying to guide the player and so on. So that's some quick summarization that the model can do. What else can it do? It can also do, behavioral and sentiment analysis, right? So in this case, if I tell it to describe the behavior and sentiments of the different people who are part of this conversation, it will now start talking about, the player's behavior, the non-playing character's behavior, the goblins and other things, the mysterious figure and so on, right? So it's able to analyze this. And one of the reasons, guys, I picked an outlandish example like this is to show you that the model is actually processing. It's not just retrieving something, it's not just doing things by rote analysis. It's actually able to extract specific parts from that text, and it's able to put that into its answer, right? Because, this is not like a typical enterprise conversation or whatever. You can also do some more interesting things, right? So you can, and now we start getting into more of the emergent behaviors that come out of the model, right? So you can tell it, based on this chat transcript, what feedback or suggestions would you offer to this player, right? To the guy who's playing the game in this particular use case. And so the model can then sort of go around and start doing, that as well. It can start giving some advice to the player, right? And again, in your heads, you guys can transpose this to your favorite use case, whether it's an enterprise use case, whether it's some other creative use case, right? But something like this, where you can start now coaching the people who are part of a conversation or the people who are trying to analyze a conversation, that becomes incredibly powerful, because now, your model is actually generating insights at that level for you, right? So that's something that you can, and again, none of these things that I'm showing you are templated, or you can always add your own sort of things. I'll if any of you have requests, I'll take those in just a moment. You can also do things that, based on the transcript, you can create things, right? So you can say, based on this video game transcript, create a tweet to advertise this game called Zephyr Dimension, right? I just, again, like I said, completely made this thing up, right? But you can basically use this for, let's say, you're a company that does marketing for things, right? And you want to generate content for these things. You want to generate a LinkedIn post, you want to generate a tweet. And, it throws in things like emojis and other things, because it knows that, for something like a tweet, virality is important. You want to hook people onto these things, right? So you can do that. You can also do the same thing, but in Spanish, right? So you can tell it, hey, do this, generate a tweet for this thing. And see, it doesn't always work. This is why I love live demos. Sometimes it works, sometimes it doesn't. Now it's spitting out text in English, right? So I have to change the prompt around a little bit now to try to make it work in Spanish. And then one last thing, which is really cool that I wanted to throw at you guys, right, is you can do more advanced sort of formatting as well, right? So you can, for example, tell it to extract the entities mentioned in the conversation, and you can now ask it to render it as a JSON file, right? So that you can consume this in your pipeline to do other things as well, right? To do further things that you want to do on from it, right? And again, remember, this is something that it's a completely made up transcript that it's never seen before, right? Yeah, I think to Srini's point in the chat, absolutely. We have a lot of use cases where people want to analyze some of their support calls, right? And they want to evaluate what is happening. Are the agents able to respond to some of these things? Absolutely, and we have a bunch of different use cases that we support with those things as well, right? Okay, I'm going to stop here while it renders that. That is the end of my talk. Let me, I think you guys have seen this. Let it keep generating. Let me go back to my last slide, which is basically this. I have links to a whole bunch of these resources, and I know I'm ending at almost 2:30, but if you have questions, I'm happy to take any questions that you guys have. Thank you.
Well, thank you so much, Kartik. This was awesome. Let's see if we have questions from the audience today. And
I do one of them. In your last step of the demo, you showed that it's extracting the last two steps. One was it extracted the actors. Is it purely like a grammar based resolution in the LLM, or is it like pre-trained to interpret some of that? Is that like purely from so if it wasn't the Zephyr game player, and let's say it was a traffic cop stopping you, pulling you over, okay, and then that was the transcript of the 911 call or whatever, is it able to say that it's a 911 caller and a 911 agent, or it has to come across it before to know that those are the actors?
So let me give you an example with, let's change the transcript, right? So this is a weekly product update, right? And if I give it the exact same prompt, right, it should just this particular instance, right? So in this case, it's able to extract that, the speakers in this case are Emily and John.
Got it.
So based, right? It's nothing. You don't have to upload any specific thing. Really, the way it's doing this is seen examples of JSON in its pre-training, right? So it knows what JSON looks like, and it knows how to extract entities. So it's putting two together and it's kind of producing that output.
Got it.
Okay.
I have a question for you. So this is just an example. So let's say for enterprise use, if somebody wants to use your system to train, so let's say I have a platform and I want to have a guide that anytime somebody get stuck on the platform or they don't know what to do, they can summon their guide and the guide helps them. They can ask questions and the guide helps them to maneuver throughout the platform. So do you train that AI for enterprise use, or let's say my developer, they have to do it themselves?
Can do, if I understand what you're trying to say, you basically want like a virtual assistant, right? That can
Right.
specific knowledge that you might have in a set of manuals, for example, right?
Your voice got cut off, so I didn't hear you. Sorry.
Can anybody else hear me?
I can hear you.
Yeah, it's kind of breaking up, but it's fine.
Stop sharing. Maybe that'll help. Yeah. So Mary, if I understood, can you guys hear me now?
Yes.
So your question, basically, you want to create a sort of virtual assistant, right?
Right.
Possible. The way I would advise somebody to do that is to first use the embedding model that I talked about, right? And so that you have in the form of the manuals or whatever it is, process manuals and so on, you send it through the embedding model, right? And then when a new query comes in from a customer, right, where they say, for example, I don't know how to log into my email, let's say, right? Then all of the stored data to retrieve the documents that are, the top results for that kind of thing. And then you give those documents to the language model so that it can generate, the response to the person accordingly. Does that make sense?
Yes. But my question was, well, all this AI model, they have to be trained based on the use that you're going to have. So let's say if I want to use your program to build the guide for my platform, do you have manpower to train the guide, or do I have to hire somebody else to use your API to do it? I'll make an example. Many years ago, we used IBM Watson to create a chatbot for our website. So when we contacted them, I had to send them all the answers and questions, everything that we needed. That in case if somebody asked, we had to send it to them, and they build a model and they connect it to the site. So that's what I'm trying to
do anything manual like that, right? So the two offerings that we offer an API for the embedding model, and we offer an API for the language model. However, on your end, if you have these documents, really all you need to do is build a vector database, maintain a vector database, and just call the API for, if you have 10,000 documents, call the embedding API 10,000 times, right?
right.
And then you can just use that with the language model. It's nothing, you don't have to generate anything manually, if that was
Okay. Thank you.
And yeah, again, if anyone's interested, here is my company's website, Symbl.ai. We have a link to Nebula from that. I think James or Soyoung, I'm sure you can post some of the links there as well. Please reach out to us, right? And we're happy to talk you through your use case.
I already bookmarked your company on my browser.
David, go ahead.
It looks like David has a question, and I think we can take one more, and then we can end the call, and feel free to connect with Kartik after.
Yes, hello. One of my questions is, this use some different kind of data for train the model. These large language models usually use semi-supervised training, when you just extract part of the data and try to make remake the data with the lost information. But it seems that this tends to make the model look more like a chat, like completing information. I want to know how in this multimodal training that you said, you can use a semi-supervised training, or this model is trained on supervised labeled data, for example.
Is it just me?
No, I couldn't hear you.
All right, this seems to be a bit of a problem. Give me 1 second.
Hello? Hello?
I got the question, but I did not hear if everybody else heard the question.
Did you hear me?
Yes, I can hear you.
So, David, to answer your question, I hope you can hear what I'm saying.
You started cutting out right after you started to answer the question.
I thought it was a joke because I didn't really hear it. But my question is basically, for training this model with multimodal data, you use semi-supervised training or labeled training, like normal supervised training?
I think it's gone. Like yeah.
I switched my networks. Can you guys hear me now?
Yes.
Yeah. Yes. So, David, it's unsupervised for the pre-training step. Again, to repeat what I was saying. And for the fine-tuning step, it's a combination of unsupervised as well as supervised data. We have some supervised that is a part of that fine-tuning data that I talked to you about. But a lot of the data is still sort of unlabeled data, so it's still unsupervised. Does that answer your question? Okay, well, hopefully it did.
Yeah. He answered in the chat.
Okay, yes, thank you. Oh, sorry, was there another question? I'm sorry about the tech issues, but luckily it happened after the talk, so.
Cool. I think that's it. For the interest of time, I think we can end the webinar for the week. Kartik, thank you so much for presenting Nebula and the use cases and demo and the awesome work that's doing. Definitely very exciting. If you can share the slides with us, we can share with the broader group who are here. You can also review today's call once we logistically get it to share. We share that on YouTube. And yeah, please connect outside of the webinar, and I look forward to everyone collaborating.
So much for I hope you guys had as much fun listening to me as I did talking. And thank you. Yep.
Thank you, everyone. See you next Friday.
Bye. Have a good weekend.
Have a great weekend.